Okay, hello everybody, and this is Apes. It's chapter 18 and then the second of the screencast of global climate change. And in this screencast, we're going to talk about the greenhouse gases. And these are atmospheric gases that exist above the Earth that will help to absorb infrared radiation, and they also help to maintain and control global climate temperatures. It is a very natural phenomenon that is made up of water vapor, ozone, carbon dioxide, nitrous oxide, methane, halocarbons, and chlorofluorocarbons, or CFCs. We've talked about this a couple of times before. You've heard it in biology, you've heard it in Apes earlier in the year. And these are gases that exist up in the atmosphere so that when the sun's energy warms the surface of the earth, the oceans, and the land, that warm air will rise and it'll start to go higher up into the atmosphere. And when it comes in contact with these greenhouse gases, the air will cool, and then it'll come back. It'll sink down much more dense to the Earth's surface. So it acts like the glass in a greenhouse, where it keeps the Earth and the temperature very warm. That's why they call them greenhouse gases. Well, what's happening is that this greenhouse effect, this very natural phenomenon where the energy travels downward and it warms the atmosphere, the planet's surface, this greenhouse effect is actually getting thicker. So kind of like blankets, you put one blanket on your bed and you're going to be warm. You add another blanket, you're going to be even warmer. A third blanket, you're even going to be warmer than that. So what happens is the more gases that we put up into the atmosphere, that thicker that global greenhouse gas blanket becomes. And instead of the air being able to reach a point where it can cool significantly, it's coming back down to the Earth at warmer temperatures. And we've talked about the significance of this because if 32 degrees is freezing, and air used to come down at 32 degrees, and that kept the polar ice caps frozen, raise that temperature just by 1 degree because you've added to that blanket, and you now have melting. And that's why the ice caps are melting. So when we think in terms of all of those different greenhouse gases that's present in the atmosphere, they all have different abilities to cause warming. So when we look at which one should we be more concerned about, we need to look at the one that causes the most warming, or the global warming potential, which is the relative ability of one molecule of a greenhouse gas to contribute to warming. So we express this in relationship to the amount of carbon dioxide that's in the atmosphere. And we say that carbon dioxide has a potential equal to 1 as far as being able to warm. So when we compare other gases, we compare them to that relationship with carbon dioxide. So methane is 25 more times more potent than carbon dioxide. Nitrous oxide is 298 times more potent than carbon dioxide. But we still hear that carbon dioxide is the most potent because carbon dioxide happens to have the largest concentrations. It's the most. So even though it only has a level of 1, when you're talking about in comparison to how much methane and how much nitrous oxide that's there's much more carbon dioxide. So much that it exerts 6 times more impact than methane does and nitrous oxide or the halocarbons combined. So that's why we're always so concerned with the amount of carbon dioxide in the atmosphere. So again, here's a table that will show you the warming potentials of those 4 greenhouse gases that we've talked about and their equivalents to carbon dioxide. Okay. Now, again, we said that this is a natural phenomenon. The greenhouse gases have always been in the atmosphere, and that's what has provided for livable environmental conditions as far as temperature is concerned. And we're not worried about that natural greenhouse effect. That's not where the problem is. What we're worried about is what is known as the anthropogenic intensification. And this is a fancy word for saying human contributions to the amount of greenhouse gases that are there. There are human activities that increase the amount of carbon dioxide in the atmosphere. And we have seen this go up from 280 parts per million to 396 parts per million by the year 2013. So we're higher than we have ever been in the last 800,000 years, and we are likely the highest that we will ever be in 20 million years. And the way that we figure this out is by simply taking core samples on the ocean floor, just drilling a core sample out of the ocean, or drilling ice samples out on the Antarctic or the Arctic, and we can see by the presence of shells how much carbon dioxide are actually trapped in those core samples, and there is a direct correlation where the more carbon dioxide that there is, the higher the temperatures were. So let's take a look at this graph, and it shows you in the green and the blue methane and nitrous oxide, which tended to just fluctuate a little bit but stay pretty steady below 300 parts per million from the beginning of the Earth time till about the time of the Industrial Revolution, and that's where the numbers started to go up. Our population numbers also started to go up at the time of the Industrial Revolution as well. Look at our carbon dioxide. It's always been below 300 parts per million except for this last century, and it has skyrocketed. It's almost up to 400 parts per million. And as we see this carbon dioxide go up, we see temperatures increase globally. So most of our carbon is stored in the upper lithosphere, and we have it in other areas, deposition, where it's deposited within the soil and the minerals. The way that it gets released is through decaying. It is compressed in the organic matter at the bottom of our forests. If it's below the surface, in the stones, it can lead to the formation of coal and oil and other natural gases. Those are our fossil fuels. Most of the time, that organic matter holds that carbon, and it remains buried for millions and millions of years. But as we use those fossil fuels and we burn more, then we wind up transferring that carbon dioxide that was sequestered or stored, and we release that into the lithospheric reserves into the atmosphere. And this is why we're seeing atmospheric carbon dioxide concentrations increasing so dramatically because our use of burning these fossil fuels. Another contributing factor to the rising atmospheric carbon dioxide levels is deforestation. We are cutting down forest and plowing under prairies, and they are our greatest recyclers of carbon dioxide. Plants use carbon dioxide in the process of photosynthesis to make sugar, to make energy. And if we continue to cut down our trees, cut down our rainforest, and we plow under our prairies and we build, then we're taking the major recyclers back. And the trees that are present, they can only hold so much carbon dioxide, and once they have absorbed their level, they can't hold any more. It would be just like if you took a cup and you filled it with water all the way to the top, and you kept trying to add more water, it's just going to overflow. And that's where our trees are. The ones that we have left, they are almost at max for the amount of carbon dioxide that they're able to store. All right, another graphic here shows you in green the natural fluxes and changes in carbon dioxide. Photosynthesis lowers it about 440 parts per million. Respiration releases it back at an equal rate. The red indicates human activity, and you can see that industry increases the amount, and there are some uptake. A little bit of uptake is increased by the plants from that human activity that goes on. And we're looking at metric tons of carbon dioxide that are being released. If you remember watching Before the Flood with Leonardo DiCaprio, one of the things that they talked about in that movie were the methane levels. And we're also seeing an increase in the amount of methane as one of the gases present in our atmospheric greenhouse gases. It has increased by 2.5-fold since 1750. What that means is it is at the highest level in over 800,000 years. And the way that this methane is being released is by tapping into those fossil fuel deposits. Any time that you access a place, oil, you're pulling out levels of methane. Livestock are going to release it when they relieve themselves with gas. Landfills, as the materials decay in landfills, or even at the bottom of the ocean when sediment settles in lakes and streams as well, it releases this methane. And there are certain crops that produce more methane as well, and rice is one of those examples. Nitrous oxide we're seeing increase. There's been a 20% increase since 1750. And we're seeing nitrous oxide coming in from feedlots for where animals are stored, herds of animals. We have a lot of chemical manufacturing plants that are releasing nitrous oxide, our cars, and then we're putting nitrogen fertilizers on our ground that are also releasing the nitrogen. So we're seeing a huge increase in that respect as well. So when we look at our concentrations, our tropospheric ozone levels have risen to about 36% in the amount of greenhouse gases that are present. Our halocarbons and our CFCs are the good news because they are declining. We're coming up with alternative methods to use in our air conditioning systems instead of Freon. We're also changing the chemicals that are in our aerosol cans. So we have seen the halocarbons and the CFCs decline. And we're happy to report as well that our water vapor, which is one of the most abundant greenhouse gases, is also remaining unchanged in the concentration levels that are present. Okay, we're going to stop there with this screencast. We'll pick up with aerosols in the next one. Enjoy.